Hello everyone. So let's see how to solve today's question. So today's question is count the number of winning sequences. So the question description, let's go through it once. So Alice and Bob are playing a fantasy battle game consisting of n rounds where they summon one of three magical creatures each round. So they are playing a game where in each round they will summon a magical creature. The magical creature can be a fire dragon, a water serpent, or an earth golem. Okay, so these are the three types of the creatures. In each round, players simultaneously summon their creature and are awarded points as follows. Okay, so in each round, both of them, like Alice and Bob, will summon creatures simultaneously, and based on their the summon of the creatures, the points will be awarded to them. So the rules are like if one player summons a fire dragon and the other summons an earth golem, the player who summoned the fire dragon is awarded a point. Okay. So between fire dragon and earth golem, the one who will get the point is the one with the fire dragon. Okay. And similarly, if the person summons serpent and the other person summons a fire dragon, then the one who summoned the water serpent will get a point. And the third one is if one person summons a earth golem and the other summons a water serpent, then the one who summoned the earth golem will win a point. Okay. And if both players summons the same creature, no player is awarded a point. So it's basically a draw in that case. You are given a string S consisting of n characters F, W, and E, representing the sequence of creatures Alice will summon in each round. Okay, so for Alice, you are given, like for the Alice, whatever creature Alice will choose, those are given in each of the rounds. Okay, so if S of I is equals to F, then that means in that ith round, the Alice will choose the fire dragon creature. Okay, and if it is S of I is equals to W, then Alice will summon a water serpent, and if in the ith round it is given as E, then Alice will summon an earth golem. Bob's sequence of moves is unknown, so the sequence is not known to us, but it is guaranteed that Bob will never summon the same creature in two consecutive rounds. Okay, so in two consecutive rounds, Bob cannot summon the same creature. So if he summoned the fire dragon in the previous round, then in the next round, in the current round, it cannot summon the fire dragon again. Okay, so this is not valid. So now Bob beats Alice if the total number of points awarded to Bob after n rounds is strictly greater than the points awarded to Alice. Okay. So if Bob, after all the rounds, the summation of points, the number of wins of Bob's is strictly greater than the wins of Alice, then we say like Bob has won. So now we want to generate the number of distinct sequences Bob can use to beat Alice. Okay, so in the number of ways, basically the number of distinct sequences, nothing but the number of ways in which Bob can beat Alice. Okay, and since the answer may be very large, return it modulo 10 to the power 9 plus 7. So that was the question description. So the example in the example it's given for the example one, the Alice sequence is given as in the first round Alice will choose the fire dragon, in the second round also the Alice will choose fire dragon, and in the third round also Alice will choose fire dragon only. Now Bob can beat Alice by making one of the following sequences of move. Suppose Bob choose water serpent in the first round, then as given in this, so if water serpent is chosen by a player against a fire dragon, then the one who chose water serpent will win. Okay, so if in this case, like Bob will get 1 point. If we take this moves, then due to choosing water serpent in the first round, Bob will get 1 point. Then again, if he chooses the same as Alice, if he also chooses Fire Dragon, then neither of them will get a point. It will be a draw. So then in the next round, if again the Bob chooses a Water Serpent, in case with Fire Dragon, then Bob will get a point. So it will be a plus one again. So if we take this example, Bob will get 2 points, Alice will get 0 point. So the Bob points are greater than Alice points. So Bob will win. So this is a valid sequence. Okay. So we don't need to generate the sequence. We just need to find out the number of sequences which are possible, or the number of ways which are possible. Okay. So similarly in this also, like the Bob will be winning 1 round, Bob will be winning 1 round, and Alice will be winning 0 round, and the draws will be two. Okay, because these two will be draw, the first one and the last one will be a draw. So Bob will win because Bob has one win, and Alice will have 0 win. So Bob will win. Note that the other winning sequence like WWE or EWW are invalid since Bob cannot make the same move twice in a row. Okay, so in this, like Bob choose W in the first round, and then again simultaneously in the next round, Bob cannot choose the same creature. So this is an invalid move. So this cannot have happened. So this winning sequence is invalid. Okay. So now after reading the question description, I think if you have solved like previously like some same similar question, so you should be getting a hint towards a DP, because in each round we have some choices like either we can choose a fire dragon, we can choose a water serpent, or we can choose a earth golem. Okay, so these three choices we have in each round, and based on these choices we need to act, and we need to find the total number of ways. So this gives a direction towards GP only. Okay, and the s dot length, so if we go to the constraint, the s dot length is 1,000. Okay, so we can go till uh, like somewhat like 1,000 into 1,000 into 100 also. Like this will be 10 to the power 8, which will be like 10 to the power 8 is still acceptable, but the better will be if we can do 1,000 to 1,000 into 10. Okay, so we can go till n is square into like some 10 something. Okay, so approx till n square we can go. So we need to get the result in that time. So now let's see how to do it. So if in the case of DP, as I told you, we have three choices. So what we will do at each time, at each move, we will just get the choice. So if in case of this, if in the first round we choose fire serpent, like the fire dragon with fire dragon, what will be the total number of ways in that case? If we choose water serpent with it, what will be the total number of ways? If we choose earth golem in it, what will be the total number of ways? And after adding all the number of ways for this current state, we can get the total number of ways to win. Okay, if I can get the total number of ways to win after this F, if I can get the total number of ways after choosing this water segment, and also after choosing this earth golem, and upon adding these, I can just simply get my answer. Okay, so we will be having like these choices, and we will be doing things on that. So let's go through the code only now, and we will see in the code how it is implemented. Also, while doing the code, we will see like will be managing like the same move should not happen twice. So if Bob has played in the previous round Fire Dragon, so he should not be allowed to play this fire dragon again. This case also we will manage. So now let's go to the code, and we will see the approach in the code. So what I have done is I have taken a DP array. So after that, I have just taken this variable mod. So as in the question description, it is given we need to take the mod. So I have taken the mod for it. So 1e9 plus 7 is 10 to the power 9 plus 7 only. So I have taken that, and after this I have created the DP array as this n. Okay, so what this n is denoting? This n is denoting the total number of rounds. Okay, so based on this string, we can see like the total number of rounds will be nothing but the length of this string. Okay, so this is the total number of round, and in each round I'll be taking the decision. So in each ith round I'll be making some decision to choose F or to choose E or to choose W. Okay, so these are the creature names only. So what is this for? This for denotes the choice of F, E, and W, and the last choice is a invalid choice. Okay, so that also I have taken. Okay, so the last one is the invalid choice. Okay, so for one of them, I'll be so suppose if I need to choose F, I can denote it through one of the values like one or two or three. Okay, so I'll be taking some integer value to denote the choice which I have taken. Okay, so to manage these DP states. Okay, so one, two, three will be my creatures. I'll be giving them some values, and zero will be the invalid. Okay, so in invalid case. So now after that I have taken this 2 into n plus 1 for the points. Okay, so the points can be at max the total sum can be if in each round Bob wins, the total points will be nothing but n only. Okay, so even if in each round the Bob wins, then the total number of points will be of n. And why I have taken 2 into n plus 1, that we will see further. Okay, so now I have just called this my DP function. I have passed in my Alice sequence, my current round or the current index. Then I have passed in the last creature which I have chosen. It is passed as 0 because previously we have not chosen any of F, E or W. So I have passed in 0. And after that I have passed the total number of points which Bob has as of now. Okay. So now let's see this function definition. Okay. So now in this count win function, what I am doing, so let's see the main logic. Okay. So what I'm doing is I am first of all getting the Alice creature over here. So what is the Alice creature? Alice creature is nothing but the value at the index position. Okay. So whatever is at the index position, that I'll be getting as the Alice creature, and then I have taken a variable to get the total number of ways. Okay. So now what I have done, if the last creature is not equals to 1. Okay, so my last creature, so what the mapping which I have done is that for F I'll be denoting it with 1, for E I'll be denoting it with 2, and for W I'll be denoting it with 3. I can also write it down. F is 1, E is 2, W is 3. Okay, so now if in the last round, if in the last round I have not taken this first creature, this F, then I in this round I can take it. Okay, so in this round I can take it. So what I'll be doing is that this Alice sequence will be passed as it is, and from the next round I need to get the total number of ways to win. And what I'm doing is that I am passing this last creature information as 1, because now I'll be choosing 1, because previously I had not chosen this, and now so say safely I can choose it, because I'm not choosing it consecutively. Okay, so then I am just updating my points. So this update points function is doing nothing but the same thing which are given as rules over here. So whatever cases I'll be having a win, I'm just doing a +1 in them, or if it's a draw, I'm doing just addition of 0. I'm not doing any add in that case, and if I'm losing, I'm just adding a -1 in that case. Okay, so that's how I'm just updating my points, and these updated points I'll be passing down in my DP call. Okay, so see, so as this choice I made, similarly I can make the choice of E. So if previously in my previous round I did not choose this 2, then in this round I can choose 2. So my next DBP call would be for S index +1, and in the previous round, as in this round I chose 2, so in the next round my last creature will be this 2, and my update points will be generated through this update points function. And after that after this all this adding, I'll be getting my answer for this DP state. Okay, for this DP state, and I'm doing a mod, as in the question it is given the answer cannot be too long, so we have to do a mod. So the main logic is clear to us, like how we'll be doing things. Okay. So now the thing is that we need to also look at these few things. Okay. Like this base case. Okay. So in this base case, what I have done is nothing but I have just written one. Okay. So whenever I'm hitting a case when the Bob's point are greater. Okay. When Bob's point are greater than Alice points, then I'm returning a 1, or else I'm returning a 0. Okay, so why in the case of points greater than 0, I know like Bob is winning. So see, in in the cases where Bob wins, I'm adding a +1, and in the cases where Alice wins, I'm doing a -1. And in the cases where none of them wins, I'm doing a 0. Okay, so suppose if you take like this, if Bob won, then again Bob won, and if then Alice won, and then if Alice won, and then suppose it was a draw, and then again Bob won. Okay, so this cumulative sum, if it is greater than 0, then I can safely say the total number of wins the total number of wins for Bob was greater. Okay, so the total number of wins for Bob was greater. So I'm returning a 1. So this is a valid case for me. So I'm returning a 1 in that case, or else I'm returning a 0. So now let's also have a look at over here. So why I'm doing this, like why I'm just not directly is storing points. So see, in the cases there can be cases where points value is negative. So suppose if Bob loses consecutively. Okay, so if Bob so suppose if Bob lose, so we can have some negative value as well for points, but we cannot store this negative value. We do not have the index for this negative value in our DP array. So how can we handle it? Okay, so how to handle is that I'm just adding a offset of this s dot length. Okay, this s dot length, I'm adding it as a offset. Okay, so suppose if my s dot length is 5. Okay, so the maximum negative value which I can have is -5. In if on in all the 5 rounds I lose, then I can have this -5. Okay, so this -5 will be mapped with 0. Okay, oh, so this -5 will be mapped with 0. This -4 will be mapped with 1. This -3 will be mapped with 2. Okay, so similarly, I'll be mapping these values, and once till over here, this 4 is mapped. So this -2 and all is mapped. So then the positive values will come. So for 1, I'll be mapping it with 6. For 2, I'll be mapping it with 7. Okay, so as you can see, there will be twice values. There will be twice the number of values in if if I take a offset. Okay, so if I take the offset, there will be twice the number of values, and hence in the beginning in my code for this points, I chose it as 2 into n plus 1. Okay, because we can have twice the twice the number of points. Okay, so I have taken this over here. So now you know like why I have taken this. So to handle the negative index, I have taken this. So what will be my time complexity? Okay, so the time complexity for this is nothing but, so see, what's the what's the index, what's the maximum index? It is of order n. This last creature is nothing but 4 values, and this is nothing but 2 into n. Okay, so if we take it overall also, what is n into 4 into 2 into n? So this will be n square into 8. So as I told you in the beginning only, like I told you in the beginning, this n square into 8 will be acceptable. Why? Because 1000 into 1000 into till 10 also is acceptable, so it is less than 10 only. So this will be accepted because it is less than 10 to the power 8. Okay, so this will be accepted. So yeah, that's about it. And what will be my space complexity? So space complexity is same only. So yeah, because the same DP size I have taken over here, and there is not a single loop or something like that in our code. So space complexity is also same as the time complexity in our case. And yeah, so that's about it. So I hope I was able to make you understand the logic. I was able to make you understand the code. So yeah, thanks for watching. And if I was able to make you understand the things, so do consider subscribing and liking to this video. Thanks.